here's a video on angle relationships, and we'll use rainbows as an example. So here's our rainbow, right? And chances are you probably won't see a rainbow like this in the sky. Be nice if you imagine if you saw something like that, but most of the time you see something like this, right? So here we have a rainbow. We have a double rainbow in this picture, right? So a rainbow, how a rainbow forms, it's like a prism. You know a prism. So here's a picture of the album cover to Pink Floyd's Dark Side of the Moon, famous album. So we know that white light comes in and comes out as a prism of colors. So the same thing happens with a rainbow. We're going to talk about water droplets and light. So basically what happens here, and we're going to do a little science here. Science and math always come together. So let's use another color. Let's see, blue. Blue is a good color. So I'll draw a raindrop. Let's say, well, a raindrop. There we go. Something like a raindrop. So we have millions of raindrops falling during a rainstorm. And the sun's light, use another color again. The sun's light is coming in at a certain angle. It's going to hit the raindrop. So the light is coming in pretty fast. As you know, light goes 186,000 miles a second. So, but when it hits the water droplet, it's going to slow down a little bit. So it's going to come in, and it's going to bend a little bit. It's going to bend a little bit. So the bending is called a refraction. The bending is a refraction. So we have a little bend. So here's the angle. And then once it hits the other side of the water droplet, it's going to reflect. It's going to reflect. So we're going to have a refraction and then a reflection. And so let me draw a better one. So let's go up here. We have our water droplet. We'll make it blue again. Make it bigger. There's our water droplet. Bring it down. So let's have the light. And we're going to see our angles. So let's say the light comes in. And then we have our refraction. And we'll talk about red light. So let's say this is a red wave. So here's the refraction part. And then it's going to reflect. It's going to reflect. So we have our reflection right here. So we have our refraction, the bending, and a reflection, the bouncing off, like a mirror. So here's the refraction. And this is the reflection. When it leaves the water droplet, it's going to refract again. So here's another. So just remember, refraction, reflection, refraction again. Refraction. Right? And that's the red you're going to see in the rainbow coming from the water droplet. And remember, there's millions of water droplets coming down from the sky. Let's bring that over so you see it better. And the different colors are going to refract and reflect. And from the prism, as you can see, red is the top, and then violet's on the bottom, and blue. They have a different refraction. They slow down. They have different speeds inside the water droplet. You don't need to know all that information. We're just going to look at the angles. Okay? So if we look at the refraction and the reflection, if you notice in the middle, there'll be this dotted line. The normal line is called, well, the line is called the normal line. This is the normal line. Normal line. So again, we have and this refraction line is called the line of incident. This is the line of incident. This is the normal line, and this is the line of reflection. And it follows a certain law. So the line of reflection, we'll say I equals R. I equals R. Where I is the line of refraction, and the R is the reflection. And they equal each other. In other words, they have the same degree, and you can see it here. Here, this degree and that degree will be even. So, and the total of them together will be even. Now, the thing about red light is it bends the least. bends the least. So red light will always come in, it'll get in, it'll exit the raindrop at a 42-degree angle. Okay, so this right here, this angle right here is 42 degrees. It's a 42-degree angle that the red is coming out. And the rest of the colors, because the blue will come out at 40 degrees, and the rest of the colors of the rainbow will fall between that 40 and 42 degrees. So the only way you're seeing a rainbow is if the sunlight comes in at a certain angle and pops out between 40 and 42 degrees. Anything more or less, you won't see the rainbow. And a person that we talked about in class in 6th grade, Rene Descartes, remember? Cogito ergo sum, I think therefore I am. So he drew this a long time ago, and during the Renaissance. And remember, Rene Descartes is the one who gives us the Cartesian grid. So here it is, we have the light coming in as he drew. So he knew this back then. And we have the refraction and the reflection and the refraction again coming out, right? And then going to the observer. And so different colors. So here we have the white light coming in, bending, and each color will bend at a certain refraction, and then it will reflect and come back again. So what you should remember is, it's between 40 and 42 degrees, and the red light, which bends the least, is 42 degrees, and the blue light is 40 degrees. Actually, the violet light is 40 degrees. The blue light's very close to that. And then just remember, we have the light coming in, you have a refraction, then a reflection, and then a refraction again. Remember that. So here's a better picture of it. Here's the water droplet. Sunlight coming in. Here's the refraction. Bounces off the other side. Here's the reflection. The refraction again. And there's the rainbow bridge of Asgard. Brimfrost, if you remember from Thor. Now, just to know that not all the light is going in here. Some light's going to be actually reflected. So only some of the light is going in. And then when it hits here, some of the light is actually going to be reflected again. It's going to come out. So light, not all the light's coming in. And remember, if you saw this dotted line, this is called, what is that line called, the dotted line? Do you remember? This is the normal line. The line of incident and the bending. In this case, the reflection. It's reflecting. It's not even bending. So here we have the normal line. And we should know that this degree and this degree will equal the same. That's all the line of reflection says. Okay, great job.